Hello dear students, let's start a new topic, empirical formula of a compound. This topic from chapter 5 of class 10th in subject chemistry. Let's open your chemistry book and come on the page number 90. First, what is the formula? What is the definition of formula? Formula, it is the symbolic representation of a molecule of a compound. It is the symbolic representation of a molecule or a compound which indicates each and every atom present in it. It gives the information regarding the chemical composition of a molecule. Let's for example, now the formula of sulfur dioxide is SO2. So sulfur dioxide is symbolically represented by the SO2, and SO2 is the formula of sulfur dioxide. So in this formula SO2, it indicates that sulfur, one atom of the sulfur and two atom of the oxygen elements are present in the sulfur dioxide. So formula is a symbolic representation of a molecule in which it indicates each and every atoms which present in the molecule. So sulfur and oxygen atom present in what ratio? That all represent in this formula. Now chemical formulae are of two types. Number one, empirical formulae and molecular formulae. So first, empirical formula of a compound. What is the empirical formula? It is the formula. Empirical formula is also a formula which gives the number of atoms of different elements present in one molecule of the compound in the simplest numerical ratio. As for example, the empirical formula of glucose is CH2O. That it means that in the glucose, carbon, hydrogen and oxygens, the three elements carbon, hydrogen and oxygen present, but their ratio always in the simplest numerical ratio. Next, the formula of hydrogen peroxide is H2O2, and but their empirical formula is HO. So HO, hydrogen and oxygen present in the hydrogen peroxide, and their in the empirical formula their ratio is the simplest. So only 1 and 1 ratio, 1:1 ratio of hydrogen and oxygen in the hydrogen peroxide. Now next term, empirical formula mass. What is the empirical formula mass? It is the sum of atomic masses of various elements present in the empirical formula. So the total sum of atomic masses of various elements which present in the empirical formula is called the empirical formula mass. As for example, in empirical formula mass of H2O2, that is empirical formula of H2O2 is hydrogen peroxide is HO. So the empirical formula mass is equal to the sum of the atomic mass of each element. That is, hydrogen has the atomic mass 1 and oxygen has the atomic mass 16. After summation we get 17. 17 is the empirical formula mass of hydrogen peroxide. Now next topic, determination of empirical formula. How can we determine the empirical formula of a compound? So empirical formula can be calculated from the percentage composition of the compound. If the percentage composition is given, then of a compound, then we can easily calculate the empirical formula of a compound. So what is the percentage composition? I will come after explaining the determination of empirical formula. I will come on this topic. What is the percentage composition of a compound? So let's go through a questions for the calculation of the empirical formula of a compound. Go through a question. It is very easy. Now consider a question. An organic compound is found to contain 54.4% carbon and 9.13% hydrogen. Determine the empirical formula of the compound. So an organic compound which contains 54.4% carbon and percentage of hydrogen equal to 9.13%. So then what is the empirical formula of that organic compound? Now here we observe that the percentage of carbon is 54.4, percentage of hydrogen is 9.13. The total percentage of carbon and hydrogen is not equal to the 100. It means that in this the organic compound oxygen also present, and the percentage composition of oxygen can be calculated by adding the percentage composition of hydrogen and carbon, and after adding subtract from the 100 value. So percentage of oxygen equal to 100 minus summation of total percentage of carbon and percentage of hydrogen, and we get 36.47%. This value is the percentage composition of the oxygen in this compound. After calculating and find out the percentage composition of all the elements, just we make a table, and this column represent the elements, and this column represent the atomic masses, and this column represent the percentage of the elements, and this column represents the relative number of moles, and in this column the simplest mole ratio, and in this column whole number ratio. So now the elements which present in this organic compound is carbon, hydrogen and oxygen. So we can write the three elements in 3 rows, and also write the atomic masses. So atomic masses of carbon is 12, hydrogen is 1, oxygen is 16, and the percentage composition of the elements which in this organic compound is, the percentage composition of carbon is 54.4, hydrogen is 9.13, oxygen is 36.47. Now then calculate the relative number of their moles by using the formula. So we divide the percentage composition of the compounds with their atomic masses. So the percentage composition of carbon is 54.4 in the formula, and their atomic mass is 12. For the hydrogen 9.13 divided by 1. For the oxygen 36.47 percentage composition, and 16 is their atomic masses. And then calculate their relative number of moles after dividing. Then simplest mole ratio can be calculated. Simplest mole ratio calculated. For calculation of the simplest mole ratio, first we choose the lowest number of the relative number of moles among these elements. So oxygen has the lowest relative number of the moles. After selection of the lowest relative number of moles, we divide the relative number of moles of each element with the lowest relative number of moles. So The relative number of moles is 4.53 for carbons, and least or lowest relative number is 2.28, and then divides. For hydrogen, 9.13 divided with lowest relative number of moles, and then solve. Now for the oxygens, the relative number of moles is 2.28 and lowest relative number of moles 2.28. After dividing and then calculating, we get 1.99 for the carbon, simplest mole ratio, and 4 for the hydrogen and 1 for the oxygens. Then we calculate the whole number ratio. So as you know that 1.99 is just near about to 2. So we can write the whole number 2, not in the fractions. And 4 is also a whole number, and 1 is also a whole number. After calculating the whole number by all the process, through this process, we multiply the whole number with their respective elements. So carbon is the whole number 2, so we multiply the carbon with 2. Hydrogen has the whole number 4, so we multiply the hydrogen with 4, and oxygen has the whole number 1, so we multiply with the 1 with the oxygens. After multiplying, we get the empirical formula of a compound C2H4O. So this is the only empirical formula of an organic compound. So through this way, we can easily calculate the empirical formula of a compound if their percentage composition is given. Okay.